Hello everyone. Today I am going to discuss one of the most confused topics in digital logic design, which is known as finite state machines. People say it's a very tricky topic, but if you know the tricks, it will be very simple for you to solve the questions. So I will discuss a few of them today. First of all, there are two types of FSMs. One is known as the Mealy sequence and other is the Moore sequence. Today I will discuss only the Mealy sequence. I'll give you an example. Let us say this is the input and I am asked to detect 1, 0 in the following sequence. Now I have to detect 1, 0 in the following sequence. Before that, I would like to tell one thing. Whenever we represent a state, we'll represent it by input / output. I'll tell you how that is used in the diagram. Now let's see. What we have to detect is 1, 0. So initially, if my input is 1, my output will be 0. Because I have to detect 1, 0 and not just 1. Next, if my input is 0, now our previous value was 1. So 1, 0 and 1, 0 both are matching. So now my output will become 1. Next, my input is 0. But my previous value was 0. So that becomes 0, 0 and my input doesn't match with 1, 0. So it is 0. Next comes 1. So 0, 1 now, but I have to detect 1, 0 doesn't match. So 0 again. Next comes 1. So 1, 1, 1, 0, they don't match, so 0 again. Next comes 0. 1, 0, 1, 0, they both match, so here again my output becomes 1. Same way, next is 1. 0, 1, 1, 0 don't match, so 0. Next is 0. 1, 0, 1, 0 both match, so it becomes 1. Same way, 0, 1, 1, 0 don't match, 0. 1, 1, 1, 0 don't match, 0 again. 1, 0, 1, 0 both match, my output is 1. 0, 1, 1, 0 they don't match, my final output is 0. So first you write like this. Now let us see the state diagram. One thing you have to remember is, here we have to detect 2 bits, 1, 0. So the number of states we will require will be 3. It's always n plus 1. So here my n is 2. So 2 plus 1, 3. So that's how I got the value 3. Now what are the 3 states? I will assume them to be 0, S0, S1 and S2. These are my 3 states. Now let's see the input. Initially, if the input is 0, it will remain at 0 only. It will remain in the same state. So I have a loop starting from 0 and ending at 0. Because what I have to detect is 1, 0. So my first bit should always be 1. So if my input is 0, it will remain in the same place. So 0, 0. This is where the representation of input and output. 0 is my input, 0 is my output. Now let's see. What if my first bit is 1? Here also I need my first bit to be 1. So then it will move to the next state S1. But my output will still be 0. So 1, 0. Next, now I have got a 1. Now let us see. What if my next state is 0? So if it is 0, 1, 0 both will match. So it will move to the next state and here you see my output becomes 1. So 0, 1. So now here I have detected the sequence 1, 0. Now we have to consider other possibilities also. Now after detecting 1, 0, what if my input is 0? If my input is 0, it will again go back to the first state. Why won't it go back to here? Because here my state was 1. but I need 0. So it will go back to the first initial state, which was 0, and I'll represent it as 0, 0. Next, if it is again 1, suppose I have 1, 0, 1. So in that case, my output will again go back to the previous state, because as I said, my previous state is 1, and I will represent it as 1/0. So this process continues, and you will see that I have detected a sequence of 1, 0 here. I hope this much is clear. We'll take one more example to understand it better. Okay, so let's see the question carefully. The state diagram of a sequence detector is shown below. State S0 is the initial state of the sequence detector. So S0 is our initial state. If the output is 1, then we have to predict the sequence which is detected. Now this might look very complicated, but I'll just tell you a simple trick. Here they have mentioned output should be 1, which means until you reach the final bit of the sequence, your output will remain 0. That's when the sequence is detected if our output is 1. So you just keep following the states till your output is 1 and don't see anything else. So let us start from S0. Now see, if I take input as 1, it will remain at the same state, so no use. Which I have to move to the next state, which means my input should be 0. So my first bit is 0. At S1, if my next bit is 0, it will remain in S1 only, and if it is 1, then only it will move to S2. So my next bit should be 1 to move from S1 to S2. Same way at S2, if my input is 1, it will go back to S0. And if it is 0, then only it will go back to S3. So I have to move from S2 to S3, which means my next bit should be 0 again. Now at S3, if we see, if my input is 1, then only it will move to S4. If it is 0, it moves back to S1. But I need to move to S4. So my next bit will be 1. Now at S4, if it is 0, my output becomes 1. Here what they have asked, the output is 1. But if it is 1, my output is 0 and I again go back to the first state. So I need my output to be 1. So my last bit should be 0. So the sequence detected is 0, 1, 0, 1, 0. Option A is the right answer. Tomorrow I'll discuss some more problems and we will see more sequence detector. Till then, feel free to comment below and like the video. Thank you.